Hi there, I'm Tiffany McCoy, and this is Show Me Horticulture, the place where Missouri roots meet the wider world of plants, science, and stories that grow from both. Today we're taking a slow walk through a fascinating idea that the chemistry of life itself is also the chemistry of medicine. From soil to cell, from a leaf to fence, to a life-saving drug, it's all connected. Have you ever thought about how much we owe to the quiet work of plants? They don't just feed us or shade us. They make molecules that have shaped entire civilizations. And it all begins with just a handful of elements: carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Those 6 tiny letters on the periodic table are life's alphabet. Everything from the scent of a rose to the proteins on our own muscles comes from them. When we talk about biochemistry, we're really talking about nature's recipe for being alive. Inside every cell, there are 4 major families of molecules that keep life running. First are proteins, the multitaskers. Made of amino cells, they fold into shapes that build muscles, digest food, and carry oxygen through our blood. Then there are lipids, the long, slippery molecules that make up cell membranes. They form the boundaries that let a cell know where it ends and the rest of the world begins, kind of like the skin of a bubble. Next up are carbohydrates, sugars and starches that store quick energy and build structure. When a plant makes cellulose for its stems, or when you eat a slice of bread, that's carbohydrates at work. And finally, nucleic acids, DNA and RNA, the blueprint keepers. They hold the instructions that tell every cell how to build, repair, and reproduce. These molecules might seem separate, but they're more like instruments in the same orchestra, each playing its part in the chemistry of life. What's truly amazing is that these same molecular patterns, the ones found in leaves, roots, and bark, also inspire medicine. Modern drugs, at their core, are molecules that tweak or mimic the chemistry already happening inside living things. Some medicines are tiny and simple, small molecule drugs like aspirin. Others are complex and alive, protein-based therapies such as insulin or monoclonal antibodies. And now we even have nucleic acid medicines like mRNA vaccines, which use genetic instructions to teach our cells how to defend themselves. No matter the form, the goal is the same: use chemistry to help the body heal itself. Long before pharmacies, people across the world steeped willow bark in water to ease aches and fevers. That bitter tea contained a molecule called salicin, which our bodies convert into salicylic acid, a natural anti-inflammatory. In the late 1800s, chemistry refined it into acetylsalicylic acid, and aspirin was born. Today, it's one of the most widely used drugs on Earth, but its roots go back to a tree growing quietly along riverbanks, including right here in Missouri. Next time you see a willow leaning over the water, you're looking at the ancestor of modern pain relief. Another plant, the opium poppy, led to some of medicine's most powerful painkillers. Inside its milky sap are alkaloids like morphine and codeine. These compounds bind to receptors in our nervous system, dulling pain signals. But with that power came danger, addiction, misuse, and heartbreak. It's a reminder that plant chemistry is potent. Nature gives us the tools. It's up to humans to use them wisely. In the forest of the Pacific Northwest, scientists once discovered that the bark of the Pacific yew tree held a molecule that could stop cancer cells from dividing. That compound, called Taxol, became a breakthrough chemotherapy drug for breast and ovarian cancers. For years, producing Taxol meant harvesting slow-growing yew trees, which raised conservation concerns. Eventually, researchers found ways to synthesize the drug and even grow it in cell cultures, preserving both forests and lives. That's another beautiful pattern in nature's chemistry. Once we understand the molecule, we can learn to recreate it sustainably. And then there's sweet wormwood, or Artemisia annua, a delicate green herb with feathery leaves. In its tissues hides artemisinin, one of the most effective antimalarial compounds ever discovered. Malaria once killed millions each year. Artemisinin changed that story, reacting with the iron in the parasite's environment to unleash free radicals that destroy the invader's proteins. Fast, powerful, and life-saving. Now scientists are exploring new uses, studying how artemisinin might slow cancer cell growth and even engineering microbes to produce it sustainably. From ancient herbal remedies to cutting-edge biotech, all from one humble plant. Of course, not every promising molecule becomes a medicine. Before a new drug reaches a patient, it must pass through the FDA approval process, a long journey that starts with laboratory discovery and ends years later with careful review. It begins in test tubes and petri dishes, moves into preclinical studies, then into 3 phases of human trials to test safety and effectiveness. Only when the evidence is clear does the FDA approve a new therapy for public use. It's a process built on both curiosity and caution, the same balance that good gardeners know well. Nurture the new, but protect what already grows. Right here in Missouri, our fields and prairies hold plants with deep medicinal stories. Black cohosh, mayapple, and purple coneflower, Echinacea purpurea. Each carry chemical secrets evolved over thousands of years to defend themselves, attract pollinators, or heal damage. For generations, indigenous communities and local herbalists learned those properties through observation and tradition long before laboratory science confirmed them. When we walk through native plant gardens today, we're walking through living libraries of medicine. Every time we clear a forest or lose a wetland, we might be erasing a cure we haven't discovered yet. That's why biodiversity isn't just beauty. It's a safeguard for our health. The chemistry of life is constantly being written and rewritten by evolution. Each new species, each fungal network underground, each seedling sprouting after a storm, all are experiments in molecular innovation. Protecting habitats is more than conservation. It's research. It's hope. Let's circle back to where we began. Proteins, lipids, carbohydrates, and nucleic acids, the basic molecules that build life, are also the inspiration for the medicines that sustain it. Aspirin from willow, morphine from poppy, Taxol from yew, artemisinin from sweet wormwood. Different plants, different stories, but the same message. The chemistry of life heals life. And Missouri's own landscapes, from Ozark woodlands to prairie meadows, are part of that same global pharmacy, still writing new chapters. So next time you walk outside, maybe along a creek lined with willows or a prairie dotted with purple coneflowers, take a moment to breathe in that living chemistry. Every scent, every color, every leaf is part of a molecular conversation that's been happening for billions of years. Nature has always been our greatest teacher and our oldest healer. Thank you for joining me on Show Me Horticulture. If you enjoyed today's episode, share it with a friend who loves plants or science, and follow the show wherever you get your podcasts. And keep an ear out for our next episode. We'll be taking a closer look at one of Missouri's own healing plants, the purple coneflower, and exploring how its roots became a symbol of resilience and natural medicine. Until next time, rooted in Missouri, branching out everywhere.